Hello, Mr. Cheroni. My name is Minh Quang from Group 2D, and today I'm excited to share our innovative solution to the laborious task of sorting. This is our team information right here, and our table contains for the project introduction. In today's fast-paced world, efficiency is crucial, but manual corn sorting remains cumbersome, especially with large quantities and various denominations. That's why our team set out to revolutionize core management using fundamental physics and our SolidWorks expertise from the reactive engineering course. With the dimensions of 150 millimeters for three sides, we aim to create a personal core sorter. Our solution that compact, efficient. We opted for a purely mechanical design to minimize complexity, eliminating the need for electronics, wiring skill, and circuit boards. This decision makes our sorter accessible and user-friendly, operating without a power short for portability. Equipped with a 3D printer, a laser cutter, and SolidWorks skill, we finalized our design. A can-shaped sorter with a three interlocking filter tray. Each tray has precisely a side hole for efficient sorting. Larger cones stay on top, while smaller cones are routed through holes. In a sense, our solution empowers efficiencies, simplify cone sorting for individuals and business alike.
Hi, my name is Khoi. So the next part of the presentation is the project concept and planning. Our planning starts by us doing research on different exist point sorting models. You can see the evaluation table right here. We have the rolling slope sorter, we have the vibrational coin sorter, and we have a rotating disc sorter. We rate them following our team criteria, and the final model we decided to choose is the vibrational coin sorter. The vibrational coin sorter prototype function by utilizing the difference in diameter between each coin variant. We have four containers corresponding to four coin variants. The largest one will stay on top, the smallest one will at the bottom. This is our paper concept prototype. Lam converted into SolidWorks. Finally, for collection concept, we will use cylinders. Each cylinder has openings of 23 millimeters in diameters. The largest coin is only 22.6, so the opening is large enough to fit all sides. This is our paper concept and our teammates converted into SolidWorks. The coin when they fold out, that will be stored in the cylinders. So for the detailed design, you can see the following figures. We have two main parts, sorter and collector. The sorter will include sorter lead, container 1, 2, 3, 4, and the cover. For the collector, we have four cylinders and one cylinder bar. My teammate will describe and go into specific of each part in the description and product development. Now we'll move on to what material we choose and why we choose it.
Finally, we're going to be talking about the materials and the budget that shall be considered for this project. First, we'll take a look at the build materials which shall be primarily used for the coin bank. This will directly impact the budget that shall make the rough estimation based on the current local market price and how we consider such statistics in the context of our project. Let's first take a look at the build materials which we have considered. Since we are looking at 3D printing for practically the entire project, we obviously have to take a look at common plastic that is used for 3D printing. It's along the lines of ABS plastic, which you have seen very common usage of, as one of industry standards. PETG and ASA were also considered but were quickly eliminated due to many constraints. Despite all the other options, however, we unanimously went for a choice that stood out to us because of its benefits. Polylactic plastic was what we went with, and it comes with plenty of great traits. First off, they are widely available and can be easily found in many 3D printing services and vendors. Of course, this pairs with the fact that PLA plastic is inexpensive, at least to its other counterparts, and this is a notable point that you shall see later in our budget estimation.
Hello, Mr. Cheroni. Now I'm going to talk about our design of team project. So first of all, here is our box. This box has a role of filtering coins operates based on the differences of the size of each type of coin. Our box basically consists of five main components. For the first part, it's located at the top of the box, which is a lid. Its role is to open when putting a mass of coins into the box and close when the box is in the process of filtering coins, in order to make sure that coins will not fall out in the process. For the second part, its purpose is to filter the largest coin, which has 22.65 millimeter in diameter. Many holes are cut inside this part with a diameter smaller than diameters of the largest coin and larger than the diameters of the second largest coin. With this method, the target is to filter and store the largest coin into this second part. The remaining coin, due to their smaller diameters, they will all fall through these holes and fall into the third part and the fourth part. Therefore, the third and the fourth parts are designed to be similar to the second part, but the hole cut in the third and the fourth parts will have different size in order to sort the second largest coin and the third largest coin. Finally, the last part will not have any hole cut. After filtering the three previous type of coin, the fourth one, which is the smallest coin, will be arranged to be stored into the last part. So this is the end of our design. Thank you for listening.
Hi everyone, I'm Nam, and I am a leader of Group 2D and as a 3D designer in this project. And let's move on to the first part. And the first part we have on the screen is the cylinders. And the cylinder is its purpose is to storing coins after sorting. So uh, the cylinders will connect it to cylinder port, what we can see on the screen right now. And the purpose of a cylinder port is like a connector between cylinders and solders. So we can pair two of that by sliding a design holder on the solder. And moving on to the solder cover. This is a solution we create to prevent dropping coin out of the solder when we shaking. And lastly is the small special things about our project is we call that coil work. So this part is can stabilize the coil direction from the top to the bottom of solders, and there are no reverse directions. And these ideas come from Khoi, and he was inspired by Vietnam fish cultures. So when the solder changes from portrait to the landscape, the smaller koi cannot move to the bigger level of larger koi. So here's the expected prototype of our project. This is the status of solder when we cover it by a solder cover, and this is the side port when we connect this port with the cylinder.
That leads us to our budget estimation. First, we have made this table based on the aforementioned research on PLA plastics and took its median pricing to be our unit of approximation. We then follow up and dig more into the printing price in Vietnam and found some rough estimates, which we'll be using before devising some formula to apply into the second table, which uses said formula to come up with these third-party printing services prices that you're seeing. And since these are just approximations, we also considered a 10% tolerance, indicating possible fluctuations in our final budget.